Question 1. The performance metrics show a consistent trend of missed sprint goals over the last 3 sprints, with a significant portion of the missed goals attributed to incomplete or inadequate testing. The team is struggling to integrate testing effectively into their agile workflow. Which of the following approaches best addresses this recurring challenge within the context of agile testing practices? Option A. Focus the next sprint review on identifying which individual team members were primarily responsible for the testing failures that led to missed sprint goals. Option B. Immediately increase the number of testing tasks assigned to individual testers in the next sprint to compensate for previous shortcomings, without further investigation into the root cause. Option C. Suggest to management that the agile methodology is not suitable for the project due to the ongoing testing challenges, and advocate for a return to a more traditional development lifecycle. Option D. Conduct a thorough sprint retrospective to analyze specific instances where testing was insufficient or blocked during sprint planning, daily stand-ups, or sprint reviews, and collaboratively define actionable improvements to the team's testing processes and communication. Correct answer is D. Conduct a thorough sprint retrospective to analyze specific instances where testing was insufficient or blocked during sprint planning, daily stand-ups, or sprint reviews, and collaboratively define actionable improvements to the team's testing processes and communication. Explanation. This scenario presents a professional challenge because the development team is experiencing a recurring pattern of missed sprint goals, which directly impacts the delivery of quality software. The challenge lies in identifying the root cause within the agile testing process and implementing corrective actions that align with professional software quality standards and ethical considerations for delivering reliable products. Careful judgment is required to ensure that the chosen approach fosters continuous improvement and maintains stakeholder trust, rather than simply assigning blame. The correct approach involves a collaborative review during the sprint retrospective to identify specific testing impediments within the sprint planning, daily stand-ups, or sprint reviews that contributed to the missed goals. This retrospective should focus on understanding why testing activities were insufficient or ineffective, leading to the identification of unmet quality criteria. For example, if sprint planning did not adequately account for testing effort, or if daily stand-ups failed to surface critical testing blockers, these would be addressed. The outcome should be actionable improvements to the team's agile processes, such as refining estimation techniques for testing tasks, improving the clarity of acceptance criteria, or enhancing communication during daily stand-ups regarding testing progress and impediments. This aligns with the professional responsibility to ensure software quality through robust processes and continuous improvement, as implicitly expected in professional software development environments. An incorrect approach would be to solely focus on individual performance during the retrospective, blaming specific testers or developers for the missed sprint goals, without analyzing the systemic issues within the agile process. This fails to address the root cause and can damage team morale, hindering future collaboration and quality efforts. It also neglects the professional obligation to foster a supportive and improvement-oriented environment. Another incorrect approach would be to bypass the retrospective entirely and simply increase the scope of testing in the next sprint without understanding the underlying reasons for the previous failures. This is inefficient, potentially wasteful, and does not address potential issues in sprint planning or daily communication that might be contributing to the problem. It demonstrates a lack of analytical rigor in problem solving, which is a hallmark of professional software quality practice. Finally, an incorrect approach would be to attribute the missed goals to external factors, without investigating how the team's internal agile testing practices could have mitigated those external impacts. Professional software quality requires proactive identification and management of risks, including those that might arise from external dependencies. The professional reasoning process for such situations involves 1. Acknowledging the observed performance issue. 2. Facilitating a blame-free retrospective focused on process improvement. 3. Identifying specific testing-related breakdowns in sprint planning, daily stand-ups, or sprint reviews. 4. Collaboratively devising and implementing actionable solutions to address these breakdowns. 5. Monitoring the effectiveness of the implemented solutions in subsequent sprints. Question 2. The monitoring system demonstrates that, while automated unit tests are passing, there has been a lack of formal code inspections, and no independent audit of the quality assurance process has been conducted prior to the planned release. Which approach best aligns with regulatory compliance for software quality professionals? Option A. Proceed with the release, as passing automated tests indicates sufficient quality, and the absence of an audit is a minor procedural oversight. Option B. Proceed with the release, but document the absence of formal inspections and audits as a known risk, relying on post-release monitoring for defect detection. Option C. Delegate the responsibility for formal inspections and audits to the development team to complete before the release deadline. Option D. Halt the release and initiate formal code inspections, and schedule an independent audit to verify adherence to quality standards and regulatory requirements. The correct answer is A. Proceed with the release, as passing automated tests indicates sufficient quality, and the absence of an audit is a minor procedural oversight. Explanation: this scenario is professionally challenging because it requires balancing the need for efficient software development with the imperative to adhere to regulatory compliance and ensure software quality. The pressure to release a product quickly can lead to shortcuts that compromise thorough testing, inspection, and auditing, potentially exposing the organization to significant risks, including regulatory penalties and reputational damage. Careful judgment is required to identify and mitigate these risks without unduly hindering progress. The correct approach involves a systematic and documented process of verification and validation activities, including testing, inspection, and auditing, integrated throughout the software development lifecycle. This aligns with the principles of software quality assurance mandated by regulatory frameworks that emphasize demonstrable evidence of compliance and risk mitigation. Specifically, regulatory guidelines for software quality professionals often require evidence of 1. Comprehensive test case execution and defect tracking. 2. Formal reviews and inspections of code, design documents, and requirements. 3. Independent audits to verify adherence to established processes and standards. This approach ensures that potential issues are identified and addressed early, reducing the likelihood of critical defects reaching production and leading to noncompliance. An incorrect approach that relies solely on informal peer reviews and ad hoc testing fails to provide the necessary objective evidence of quality and compliance. Regulatory bodies require documented evidence that processes have been followed and that software meets specified quality attributes. Informal methods lack the rigor and traceability needed to satisfy these requirements. Another incorrect approach that prioritizes automated testing over manual inspection and formal reviews overlooks the value of human expertise in identifying subtle defects, usability issues, and potential security vulnerabilities that automated scripts might miss. While automation is crucial for efficiency, it is not a substitute for all quality assurance activities. Regulatory expectations often include a mix of testing types and review processes to ensure comprehensive coverage. An incorrect approach that postpones all quality assurance activities until the final stages of development is also professionally unacceptable. This reactive approach significantly increases the cost and difficulty of fixing defects, as they may be deeply embedded in the system. It also heightens the risk of missing critical issues that could lead to regulatory noncompliance or product failure, as there is insufficient time for remediation before release. Regulatory frameworks generally advocate for a proactive, integrated approach to quality assurance. Professionals should employ a decision-making framework that prioritizes understanding the specific regulatory requirements applicable to the software being developed. This involves identifying the mandated quality assurance activities, the required documentation, and the acceptable levels of risk. The framework should then guide the selection and implementation of appropriate SQC activities, ensuring they are integrated into the development lifecycle and that their effectiveness is objectively verifiable. Continuous monitoring and adaptation of these activities based on feedback and evolving risks are also essential. Question 3. Upon reviewing the test plan for a new financial reporting module, a software quality professional observes that the proposed test design techniques primarily rely on the subjective judgment of senior developers based on their past experiences with similar modules. The module is subject to stringent regulatory oversight regarding data integrity and accuracy. Which test design technique approach best aligns with professional best practices and regulatory expectations for this scenario? Option A. Focusing exclusively on positive test cases to validate expected system behavior. Option B. Conducting exhaustive testing of all possible input combinations to ensure complete coverage. Option C. Employing a combination of equivalence partitioning and boundary value analysis to systematically cover input data domains. Option D. Relying solely on experience-based testing by senior developers to identify potential defect areas. The correct answer is C. Employing a combination of equivalence partitioning and boundary value analysis to systematically cover input data domains. Explanation. This scenario presents a professional challenge because the software development team is under pressure to deliver a new feature quickly, potentially leading to shortcuts in the testing process. The quality professional must balance the need for timely delivery with the imperative to ensure the software meets quality standards and regulatory compliance. The challenge lies in selecting the most effective test design technique that provides adequate coverage without introducing undue delays. The correct approach involves selecting a technique that offers a balance between thoroughness and efficiency, aligning with industry best practices for software quality assurance. Specifically, equivalence partitioning and boundary value analysis are considered best practices because they systematically reduce the number of test cases required while maximizing the likelihood of detecting defects. Equivalence partitioning groups input data into classes where all members are expected to be processed similarly, thus reducing redundant testing. Boundary value analysis focuses on testing at the edges of these equivalence partitions, as defects are often found at these critical points. This combination ensures comprehensive testing of input domains and is a widely accepted standard in software quality professional practice, implicitly supported by general principles of due diligence and risk management expected in regulated environments. An incorrect approach would be to solely rely on experience-based testing without a structured methodology. While experienced testers can identify potential problem areas, this method lacks systematic coverage and can be subjective, leading to missed defects and potential non-compliance with quality standards. It fails to provide a repeatable and auditable testing process, which is often a requirement in quality assurance frameworks. Another incorrect approach is to perform exhaustive testing without regard for efficiency. While theoretically ideal for finding all defects, exhaustive testing is often impractical and prohibitively expensive for complex software. It does not represent a professional or risk-based approach to testing and can lead to significant delays, impacting project timelines and potentially violating service-level agreements or market release commitments. A third incorrect approach would be to focus only on positive test cases, neglecting negative test cases. This oversight fails to adequately test how the system handles invalid or unexpected inputs, which is a critical aspect of robust software design and a common source of defects. Regulatory compliance often mandates that software be resilient to a range of input conditions, including erroneous ones. Professionals should approach such situations by first understanding the project's risk profile and quality objectives. They should then evaluate available test design techniques based on their ability to achieve the required test coverage efficiently and effectively. A structured, documented approach that can be justified and audited is paramount. When faced with time constraints, the decision-making process should prioritize techniques that offer the best return on investment in terms of defect detection and risk mitigation, rather than resorting to ad hoc or incomplete methods. Question 4. Compliance review shows that the acceptance testing phase for new financial reporting software has been completed, but the process for gathering and evaluating end-user feedback was largely informal and lacked clearly defined acceptance criteria. The development team is now considering releasing the software based on the general sentiment that users liked it. What is the most appropriate next step to ensure quality and compliance? Option A. Proceed with the release as planned, as the informal feedback indicates general user satisfaction, and address any minor issues that arise post-release. Option B. Conduct a limited, targeted retesting of specific features that users expressed minor concerns about, and then proceed with the release. Option C. Formalize the acceptance criteria, review the collected user feedback against these criteria, prioritize any identified deviations or defects, and plan for their resolution before release. Option D. Delay the release indefinitely until a comprehensive, formal acceptance testing cycle can be re-executed with a new set of users. The correct answer is C. Formalize the acceptance criteria, review the collected user feedback against these criteria, prioritize any identified deviations or defects, and plan for their resolution before release. Explanation. This scenario presents a common challenge in software quality assurance, ensuring that acceptance testing, a critical phase involving end users or stakeholders, is conducted effectively and aligns with regulatory expectations. The challenge lies in balancing the need for user feedback with the structured requirements of quality processes and potential regulatory compliance. Professionals must navigate potential conflicts between user desires and documented requirements, and ensure that the testing process itself is robust enough to identify defects that could impact compliance or user satisfaction. Careful judgment is required to define the scope of acceptance testing, manage user expectations, and integrate feedback into the development lifecycle without compromising the overall quality or regulatory adherence. The correct approach involves a structured and documented process for acceptance testing, where user feedback is systematically gathered, analyzed against defined acceptance criteria, and prioritized for resolution. This aligns with the principles of good software engineering practice and regulatory frameworks that often mandate clear traceability from requirements to testing and defect resolution. By involving end users in a controlled manner, organizations can validate that the software meets business needs and functions as intended, thereby reducing the risk of post-release issues and ensuring compliance with any relevant industry standards or regulations. This systematic approach fosters accountability and provides an auditable trail of user validation. An incorrect approach that relies solely on informal feedback or subjective user opinions without defined acceptance criteria fails to provide a measurable basis for acceptance. This can lead to scope creep, unresolved critical issues, and a lack of auditable evidence for compliance. It also risks overlooking defects that may not be immediately apparent to the end user, but could have significant implications for data integrity, security, or operational efficiency, potentially violating regulatory mandates. Another incorrect approach that prioritizes immediate user satisfaction over addressing identified defects, even critical ones, poses a significant regulatory risk. This can result in the release of software that is non-compliant or unstable, leading to potential penalties, reputational damage, and a failure to meet the intended quality standards. It undermines the integrity of the testing process and demonstrates a disregard for established quality assurance protocols. A further incorrect approach that excludes key stakeholders or end users from the acceptance testing phase entirely is also professionally unacceptable. This deprives the project of crucial real-world validation, increasing the likelihood of delivering a product that does not meet user needs or operational requirements. It also creates a gap in the quality assurance process, making it difficult to demonstrate that the software has been adequately tested and validated against its intended use, which can be a critical failure in regulated environments. The professional decision-making process for such situations should involve clearly defining acceptance criteria upfront, establishing a formal process for user involvement and feedback collection, prioritizing defects based on their impact on functionality and compliance, and ensuring that all acceptance testing activities are documented and traceable. Professionals should advocate for a balanced approach that incorporates user perspectives, while maintaining the rigor of the quality assurance process and adhering to all applicable regulatory requirements. Question 5. Benchmark analysis indicates that a software development project is experiencing a divergence between the documented technical specifications and the evolving needs of the end users, leading to potential dissatisfaction despite meeting all formal requirements. As the SQP, which approach best defines and ensures quality in this situation? Option A. Focus primarily on ensuring the software is functional and usable for its intended purpose, even if it deviates from initial specifications. Option B. Emphasize achieving immediate end-user satisfaction through iterative adjustments, even if it means compromising on formal requirements and overall product robustness. Option C. Prioritize a holistic definition of quality that integrates meeting documented requirements, ensuring fitness for purpose, and achieving customer satisfaction. Option D. Strictly adhere to the documented technical specifications, assuming they fully capture the intended quality. The correct answer is C. Prioritize a holistic definition of quality that integrates meeting documented requirements, ensuring fitness for purpose, and achieving customer satisfaction. Explanation. Scenario analysis. This scenario is professionally challenging because it requires a software quality professional, SQP, to balance competing interpretations of quality in a real-world project context. The tension between strictly adhering to documented requirements, ensuring the software functions as intended for its intended use, and achieving genuine customer satisfaction presents a common dilemma. A failure to navigate this effectively can lead to project delays, budget overruns, reputational damage, and ultimately, a product that does not deliver its intended value. The SQP must exercise sound judgment to determine which aspect of quality takes precedence or how to integrate them harmoniously. Correct approach analysis. The correct approach involves prioritizing a holistic definition of quality that encompasses meeting documented requirements, ensuring fitness for purpose, and achieving customer satisfaction. This aligns with the fundamental principles of software quality as understood within professional software engineering standards. Meeting requirements is the baseline, but fitness for purpose acknowledges that requirements might be incomplete or misinterpreted, and the software must still be usable and effective for its intended application. Customer satisfaction is the ultimate measure of success, reflecting whether the software truly solves the user's problem and meets their expectations, even if those expectations extend beyond the initial specifications. This integrated approach is ethically sound as it aims to deliver maximum value and avoid technical debt or user frustration, thereby upholding the professional's duty to their stakeholders and the end users. Incorrect approach is analysis, focusing solely on meeting documented requirements without considering fitness for purpose or customer satisfaction, represents a failure to deliver true quality. While technically compliant, the software might be unusable, inefficient, or fail to address the underlying business need, leading to significant dissatisfaction and wasted investment. This approach can be ethically questionable as it prioritizes form over substance, potentially misleading stakeholders about the actual value delivered. Prioritizing only fitness for purpose, without strict adherence to documented requirements, can lead to scope creep and unpredictable development. While the software might be functional, it may deviate significantly from the agreed-upon scope, causing issues with integration, testing, and stakeholder alignment. This can also be ethically problematic if it leads to a product that doesn't meet contractual obligations or regulatory mandates that were tied to specific requirements. Emphasizing only customer satisfaction, without regard for documented requirements or fitness for purpose, can result in a product that is a moving target, constantly changing to appease immediate feedback without a stable foundation. This can lead to a technically unsound product, significant rework, and an inability to meet broader organizational or regulatory objectives. Ethically, this approach can be irresponsible if it leads to a product that is not robust, secure, or compliant with necessary standards, even if the immediate customer is pleased. Professional reasoning. Professionals should employ a decision-making framework that starts with understanding the project's context and stakeholder expectations. This involves clearly defining what quality means for the specific project, considering all three facets: requirements, fitness for purpose, and customer satisfaction. A balanced approach where each aspect informs the others is crucial. When conflicts arise, a structured risk assessment and communication strategy with stakeholders are essential to make informed decisions about trade-offs, ensuring transparency and alignment on the definition of success. Question 6. Examination of the data shows that a software development project has incurred significant external failure costs due to customer-reported bugs and product returns. Prevention costs, such as training and process improvement initiatives, are relatively low, and appraisal costs, including testing and inspections, are moderate, which strategic recommendation best aligns with the principles of effective quality management and the professional responsibilities of a software quality professional. Option A. Recommend immediate and significant reductions in appraisal costs by streamlining testing procedures and reducing the scope of quality assurance reviews to free up resources for addressing external failures. Option B. Suggest a reallocation of funds from prevention and appraisal to solely address the immediate external failure costs, aiming to quickly resolve customer complaints. Option C. Propose the elimination of all prevention costs, arguing that the focus should be entirely on reactive measures to fix defects once they are reported by customers. Option D. Advocate for a substantial increase in investment in prevention activities, such as enhanced developer training and proactive design reviews, and a moderate increase in appraisal activities, such as expanded test coverage and automated testing, to identify and mitigate defects early in the development lifecycle? The correct answer is D. Advocate for a substantial increase in investment in prevention activities, such as enhanced developer training and proactive design reviews, and a moderate increase in appraisal activities, such as expanded test coverage and automated testing, to identify and mitigate defects early in the development lifecycle. Explanation: this scenario is professionally challenging because it requires a software quality professional, SQP, to interpret financial data related to quality efforts and make strategic recommendations based on a nuanced understanding of quality cost categories. The challenge lies in moving beyond simple data reporting to proactive quality improvement and cost optimization, aligning with the core responsibilities of an SQP. Careful judgment is required to distinguish between activities that genuinely contribute to long-term quality and those that may appear cost-effective in the short term, but lead to greater expenses later. The correct approach involves recognizing that while prevention and appraisal costs are investments, failure costs represent inefficiencies and potential damage. A strategic SQP would advocate for increasing investment in prevention and appraisal activities, as these are designed to identify and mitigate defects before they impact the customer or incur significant rework. This aligns with the fundamental principles of quality management, which emphasize proactive defect prevention over reactive defect correction. Regulatory frameworks for software quality often implicitly or explicitly encourage such proactive measures to ensure product reliability, security, and customer satisfaction, thereby minimizing potential liabilities and reputational damage associated with external failures. An incorrect approach would be to focus solely on reducing the highest immediate cost category, which in this case appears to be external failure costs. While reducing external failures is a desirable outcome, attempting to achieve this by simply cutting prevention and appraisal budgets is counterproductive. This would be a regulatory and ethical failure, because it neglects the fundamental responsibility of the SQP to ensure product quality and safety. Reducing investment in testing, appraisal, or training prevention to mask external failures in the short term is a form of misrepresentation of the true state of quality and could lead to increased risks, potential non-compliance with industry standards or regulations, and ultimately, greater financial and reputational harm. Another incorrect approach would be to advocate for the elimination of all appraisal costs, arguing that prevention alone should suffice. This is flawed because appraisal serves as a critical verification step, ensuring that prevention efforts are effective and that defects are caught before release, even with robust prevention mechanisms. Neglecting appraisal would increase the likelihood of external failures, violating the professional duty to deliver reliable software. The professional decision-making process for similar situations should involve a thorough analysis of the quality cost data, identifying root causes for high failure costs, and then developing a strategic plan that prioritizes investments in prevention and appraisal. This plan should be communicated to stakeholders, highlighting the long-term benefits of such investments in terms of reduced overall costs, improved customer satisfaction, and enhanced product reliability, all of which are critical for regulatory compliance and professional integrity. Question 7. Assessment of which approach best integrates the core philosophies of Deming, Jurin, and Crosby for establishing a comprehensive quality framework in a new software development project, aiming for both defect prevention and continuous improvement. Option A. A framework that prioritizes statistical process control to monitor variations in development metrics without explicit quality planning or defect prevention goals. Option B. A framework that concentrates on quality control measures to identify and correct defects after they have occurred, with minimal emphasis on upfront planning or systemic improvement. Option C. A framework that emphasizes continuous improvement cycles, proactive quality planning, and a commitment to defect prevention as a primary goal. Option D. A framework that solely focuses on achieving zero defects through rigorous inspection and testing at the end of the development cycle. The correct answer is C. A framework that emphasizes continuous improvement cycles, proactive quality planning, and a commitment to defect prevention as a primary goal. Explanation: this scenario presents a professional challenge because it requires a software quality professional to balance the immediate demands of a project with the long-term strategic implementation of quality principles. The challenge lies in discerning which quality philosophy, when applied to a new software development project, will yield the most sustainable and effective quality outcomes, aligning with both project goals and broader organizational quality objectives. Careful judgment is required to avoid superficial adoption of quality buzzwords and instead focus on the underlying principles that drive genuine quality improvement. The correct approach involves integrating Deming's philosophy of continuous improvement, plan, do, check, act, cycle, and his emphasis on understanding system variation, alongside Juran's focus on quality planning, control, and improvement, and Crosby's concept of zero defects as a goal and prevention over inspection. This approach is correct because it draws upon the foundational principles of established quality gurus, recognizing that a holistic application of their philosophies is more effective than adopting a single, potentially narrow, perspective. Specifically, Deming's systemic view encourages proactive identification and mitigation of root causes of defects. Juran's structured approach ensures quality is built into the process from the outset, and Crosby's zero defects mindset provides a clear aspirational target. This integrated approach aligns with the spirit of professional software quality management, which aims for robust, reliable, and defect-free software through systematic processes and a culture of quality. An incorrect approach that focuses solely on Crosby's zero defects, without considering the systemic causes of defects Deming, or the planning and control mechanisms Juran, is flawed. This is because it risks creating a culture of blame or superficial fixes rather than addressing underlying process issues, potentially leading to missed opportunities for fundamental improvement and an unsustainable pursuit of perfection without the necessary framework. Another incorrect approach that emphasizes only Juran's quality control aspects without the proactive prevention and continuous improvement elements of Deming and Crosby would be insufficient. This would lead to a reactive quality process, focusing on detecting defects rather than preventing them, which is less efficient and less aligned with modern quality paradigms that prioritize building quality in from the start. A third incorrect approach that solely adopts Deming's statistical process control without the practical implementation of quality planning and the aspirational goal of zero defects would miss crucial elements of a comprehensive quality strategy. While statistical methods are vital, they need to be integrated with planning and a clear quality objective to be fully effective in a software development context. The professional decision-making process for similar situations should involve 1. Understanding the project context and its specific quality requirements. 2. Evaluating the strengths and potential limitations of different quality philosophies in relation to the project and organizational culture. 3. Synthesizing principles from multiple, complementary quality gurus to create a tailored and robust quality strategy. 4. Prioritizing proactive measures and continuous improvement over purely reactive defect detection. 5. Fostering a culture of quality that is embedded within the development lifecycle. Question 8. Which approach would be most appropriate for addressing a critical software defect discovered just before the scheduled release, which impacts a core user function and has potential implications for data integrity? Option A. Release the software as planned and immediately begin working on a patch to be deployed as soon as possible. Option B. Halt the release indefinitely until a perfect, bug-free version can be developed. Option C. Conduct a thorough root cause analysis, perform a comprehensive impact assessment, develop and rigorously test a validated fix before release. Option D. Implement a quick workaround for the defect and plan to address it with a post-release patch. The correct answer is C. Conduct a thorough root cause analysis, perform a comprehensive impact assessment, develop and rigorously test a validated fix before release. Explanation. This scenario presents a common challenge in software quality control where a critical defect is discovered late in the development cycle, impacting a core functionality. The professional challenge lies in balancing the urgency to release a functional product with the imperative to maintain high quality and adhere to regulatory standards, particularly those governing data integrity and user safety. The decision requires careful consideration of the potential impact of the defect, the effectiveness of proposed solutions, and the implications for compliance. The correct approach involves a thorough root cause analysis to understand the origin of the defect and its potential ripple effects. This is followed by a comprehensive impact assessment, evaluating the severity of the defect on user experience, data integrity, and any regulatory compliance requirements. Based on this assessment, a robust, validated fix is developed and rigorously tested to ensure it resolves the defect without introducing new issues. This systematic process aligns with the principles of good software engineering practice and regulatory expectations for quality assurance, ensuring that the software meets its intended purpose and does not pose undue risks. An incorrect approach that prioritizes a quick, superficial fix without understanding the root cause risks, leaving latent defects or introducing new ones, potentially leading to future failures and noncompliance. This bypasses essential quality gates and regulatory due diligence. Another incorrect approach, which involves releasing the software with a known critical defect and relying solely on post-release patches, demonstrates a disregard for user safety and data integrity, directly contravening regulatory obligations to deliver fit-for-purpose software. This approach also undermines stakeholder trust and can lead to significant reputational damage and legal repercussions. A third incorrect approach, which involves delaying the release indefinitely without a clear plan to address the defect, is also professionally unsound, as it fails to meet business objectives and stakeholder expectations for timely delivery, indicating poor project management and an inability to effectively resolve quality issues. Professionals should employ a structured decision-making process that begins with understanding the problem thoroughly, assessing its impact against established quality criteria and regulatory mandates, evaluating potential solutions based on their effectiveness and risk, and then implementing the chosen solution with rigorous verification and validation. This ensures that quality is built into the process and that compliance is maintained throughout the software development lifecycle. Question 9. Implementation of a new financial reporting module requires the creation of test cases. The project team is under pressure to accelerate the testing phase, which approach to defining test cases best ensures both thoroughness and compliance with potential regulatory oversight for software quality professionals. Option A. Focus on outlining the main functional steps and the primary inputs, assuming that testers can infer expected outputs and pass/fail status based on general system behavior. Option B. Define detailed steps, specific inputs, precise expected outputs for each step, and clear, objective pass/fail criteria for all test cases, including those covering error conditions and boundary values. Option C. Prioritize the creation of a large number of test cases covering basic functionality, with minimal detail on expected outputs or pass/fail criteria to maximize test coverage breadth. Option D. Document only the high-level functional requirements that the test cases are intended to cover, leaving the specifics of steps, inputs, and outputs to the discretion of individual testers. The correct answer is B. Define detailed steps, specific inputs, precise expected outputs for each step, and clear, objective pass/fail criteria for all test cases, including those covering error conditions and boundary values. Explanation. This scenario presents a professional challenge because it requires a software quality professional to balance the need for comprehensive test case documentation with the practical constraints of project timelines and resource availability. The core of the challenge lies in ensuring that test cases adequately cover all critical aspects of the software, including functional requirements, error handling, and boundary conditions, while also being efficient and maintainable. A failure to meticulously define steps, inputs, expected outputs, and pass/fail criteria can lead to ambiguous testing, missed defects, and ultimately a product that does not meet quality standards or regulatory compliance. The correct approach involves a systematic and thorough definition of each component of a test case. This includes clearly outlining the precise steps to execute the test, specifying the exact inputs required for each step, detailing the expected output or system behavior after each input is applied, and establishing unambiguous pass/fail criteria that leave no room for subjective interpretation. This meticulousness is crucial for ensuring reproducibility of tests, facilitating defect reporting, and providing a clear audit trail for quality assurance activities. From a regulatory perspective, particularly within frameworks that mandate demonstrable quality and compliance, such as those governing financial services or medical devices, depending on the SQP exam-specific jurisdiction, well-defined test cases are essential evidence of due diligence and adherence to established quality management systems. They provide objective proof that the software has been tested against its requirements and that defects have been identified and resolved. An incorrect approach that prioritizes speed over completeness by omitting detailed expected outputs and pass/fail criteria is professionally unacceptable. This failure directly contravenes the principle of verifiable testing. Without clearly defined expected outputs, testers may incorrectly mark a test as passed when the system behaves unexpectedly, leading to the release of defective software. Similarly, vague or absent pass/fail criteria introduce subjectivity, making it impossible to objectively determine if a test has been successful. This lack of rigor can result in noncompliance with quality standards and regulatory requirements that demand objective evidence of testing effectiveness. Another incorrect approach that focuses solely on functional steps and inputs, neglecting error handling and boundary conditions, is also professionally deficient. This oversight can lead to software that performs well under ideal conditions, but fails catastrophically when encountering unexpected inputs or edge cases. Regulatory frameworks often require that software be robust and resilient, capable of handling a wide range of operational scenarios. Failing to test these critical areas means the software may not meet these implicit or explicit regulatory expectations, posing risks to users and the organization. The professional decision-making process for such situations should involve a risk-based assessment. The software quality professional must evaluate the criticality of the functionality being tested, the potential impact of defects in that area, and the specific regulatory requirements applicable to the software. This assessment should guide the level of detail and rigor applied to test case design. When in doubt, erring on the side of more detailed and comprehensive test cases is generally the safer and more professional choice, as it provides better assurance of quality and compliance. Question 10. Strategic planning requires a proactive approach to software quality assurance. Considering the pressure to accelerate feature delivery, which unit testing strategy best upholds regulatory compliance and professional integrity for a software quality professional? Option A. Implement comprehensive unit tests for all new code, ensuring their automated execution and reporting as part of the continuous integration pipeline, even for features intended for rapid deployment. Option B. Focus unit testing efforts primarily on established core functionalities, with minimal testing applied to newly developed or rapidly iterated modules. Option C. Conduct unit testing manually for all new code, prioritizing speed over automated execution and comprehensive test coverage. Option D. Defer unit testing for features designated for rapid release, relying on subsequent integration and system testing to identify and rectify any component-level defects. The correct answer is A. Implement comprehensive unit tests for all new code, ensuring their automated execution and reporting as part of the continuous integration pipeline, even for features intended for rapid deployment. Explanation. This scenario presents a professional challenge because it requires balancing the immediate need for rapid feature delivery with the long-term imperative of maintaining software integrity and compliance. The pressure to release new functionality quickly can lead to shortcuts in quality assurance, potentially introducing defects that could have significant downstream consequences, including regulatory noncompliance and reputational damage. Careful judgment is required to ensure that unit testing, a foundational element of software quality, is not compromised. The correct approach involves prioritizing the development and execution of comprehensive unit tests for all new code, including those for features intended for rapid deployment. This ensures that individual components function as expected before integration, reducing the likelihood of defects propagating through the system. From a regulatory perspective, particularly within frameworks like those governing financial services or healthcare software, depending on the specific SQP exam jurisdiction, robust testing is often a mandated requirement for demonstrating due diligence and ensuring the reliability and security of software. Failing to adequately unit test can lead to non-compliance with standards that require verifiable quality assurance processes. An incorrect approach would be to defer unit testing for features slated for rapid release, assuming that integration testing or later stage testing will catch any issues. This is ethically unsound, as it knowingly introduces risk into the software development lifecycle. It also represents a regulatory failure, because it bypasses a critical quality gate, potentially violating regulations that mandate thorough testing at the component level to ensure software integrity and prevent the release of faulty products. Another incorrect approach is to focus unit testing solely on core, established functionalities, while neglecting new or rapidly developed modules. This creates a quality gap, where newer parts of the system are less scrutinized, increasing the probability of introducing subtle but critical bugs. This is a professional failing because it demonstrates a lack of commitment to consistent quality across the entire codebase and can lead to regulatory scrutiny if the untested components are found to be the source of defects impacting compliance. Finally, an incorrect approach would be to rely on manual verification of unit test results rather than automated execution and reporting. While manual review has its place, it is prone to human error and is not scalable for the frequent testing required in agile environments. This approach undermines the efficiency and reliability of the unit testing process, potentially leading to missed defects and a failure to meet regulatory expectations for repeatable and verifiable testing procedures. Professionals should adopt a decision-making framework that integrates quality assurance into the earliest stages of development. This involves understanding the regulatory landscape relevant to the software being developed and ensuring that unit testing practices align with these requirements. When faced with pressure to expedite releases, professionals must advocate for the necessary time and resources to perform thorough unit testing, framing it not as a delay but as a critical risk mitigation strategy that protects both the organization and its users from potential harm and regulatory penalties. Question 11. During the evaluation of a software project, the SQA engineer reports a significant increase in the number of critical defects found during the latest testing cycle, exceeding the project's quality targets. The SQA manager is concerned about the potential impact on the release timeline and product quality. Considering the distinct but complementary responsibilities of the SQA manager and SQA engineer, which of the following actions best reflects their professional duties in addressing this situation? Option A. The SQA manager should schedule a meeting with the SQA engineer to collaboratively analyze the root causes of the increased defect rate, discuss potential adjustments to the testing strategy, and jointly propose solutions to the project team. Option B. SQA manager should immediately instruct the SQA engineer to extend testing hours for all team members and increase the number of test cases executed, while the SQA engineer should focus solely on documenting and reporting all identified defects. Option C. The SQA engineer should independently decide to halt all further testing until the development team can guarantee a defect-free build, without consulting the SQA manager. Option D. The SQA manager should dismiss the increased defect rate as a temporary fluctuation and instruct the SQA engineer to proceed with the original testing plan to avoid delaying the project. The correct answer is B. The SQA manager should immediately instruct the SQA engineer to extend testing hours for all team members and increase the number of test cases executed, while the SQA engineer should focus solely on documenting and reporting all identified defects. Explanation: this scenario presents a professional challenge due to the inherent conflict between the SQA manager's strategic oversight and the SQA engineer's tactical execution, particularly when resource constraints impact quality objectives. The SQA manager is responsible for establishing quality policies and processes, ensuring alignment with organizational goals, and managing the overall SQA function. The SQA engineer is tasked with implementing these processes, conducting tests, and identifying defects. Misinterpreting or misapplying their respective roles can lead to compromised software quality, missed deadlines, and inefficient resource allocation. Careful judgment is required to balance the immediate needs of defect resolution with the long-term strategic goals of quality assurance. The correct approach involves the SQA manager actively engaging with the SQA engineer to understand the root causes of the increased defect rate and collaboratively developing a revised testing strategy. This approach aligns with the principles of effective quality management, emphasizing communication, problem-solving, and adaptive planning. The SQA manager's responsibility extends to ensuring that the SQA team has the necessary resources and support to meet quality objectives. By working together, they can identify whether the increased defects stem from development issues, inadequate testing procedures, or insufficient testing time, and then implement appropriate corrective actions, such as reallocating resources, refining test cases, or providing additional training. This collaborative problem-solving is a cornerstone of professional SQA practice, aiming to improve the software development lifecycle and deliver high-quality products. An incorrect approach would be for the SQA manager to unilaterally mandate increased testing hours without understanding the underlying issues. This fails to address the root cause of the defects and can lead to engineer burnout and decreased morale, potentially exacerbating the problem. It also bypasses the SQA engineer's expertise in identifying specific testing needs and challenges. Another incorrect approach would be for the SQA engineer to solely focus on documenting defects without escalating the systemic issues or proposing solutions to the SQA manager. This reactive stance, while fulfilling the immediate task of defect reporting, neglects the SQA engineer's role in contributing to process improvement and proactive quality assurance. It also fails to leverage the SQA manager's authority and responsibility to implement broader organizational changes. A further incorrect approach would be for the SQA manager to dismiss the increased defect rate as a temporary anomaly and continue with the original plan. This demonstrates a lack of responsiveness to critical quality indicators and a failure to adapt to changing project realities, potentially leading to significant quality issues and reputational damage. It also undermines the SQA engineer's efforts to highlight potential problems. The professional decision-making process for similar situations should involve a structured approach. First, actively listen to and understand the concerns raised by the SQA engineer, seeking to identify the root causes of the observed issues. Second, assess the impact of these issues on project timelines, budget, and overall quality objectives. Third, collaborate with the SQA engineer and potentially the development team to brainstorm and evaluate potential solutions. Fourth, develop and implement a revised plan, ensuring clear communication of roles, responsibilities, and expectations. Finally, monitor the effectiveness of the implemented changes and be prepared to iterate as necessary. This iterative and collaborative process ensures that quality is managed proactively and effectively. Question 12. Strategic planning requires a software quality professional to select the most effective testing approach for a system governed by complex business rules that can be represented by a decision table. Given the regulatory framework for the software quality professional (SQP) exam, which of the following approaches best ensures compliance and robust quality assurance? Option A. Prioritize the creation of a minimal set of test cases that cover the most frequently used business rules, even if it means not fully representing the decision logic. Option B. Select a representative sample of conditions from the decision table and create test cases based on these selected conditions only. Option C. Systematically derive test cases from the decision table, ensuring coverage of all condition combinations and their corresponding action, including valid and invalid scenarios. Option D. Focus test case creation solely on the happy path scenarios, assuming that invalid or edge cases are less critical for this system. The correct answer is C. Systematically derive test cases from the decision table, ensuring coverage of all condition combinations and their corresponding actions, including valid and invalid scenarios. Explanation. This scenario is professionally challenging because it requires a software quality professional to balance the need for comprehensive testing with the practical constraints of project timelines and resources. The core of the challenge lies in selecting the most effective and compliant testing strategy when faced with a complex set of business rules that can be represented by a decision table. The professional must not only understand the technical aspects of decision table testing, but also its implications within the regulatory framework governing software quality for the specified exam jurisdiction. The correct approach involves meticulously developing test cases that cover all valid and invalid combinations of conditions and actions, as defined in the decision table. This ensures that the software behaves as expected under all specified circumstances, directly addressing the regulatory requirement for robust quality assurance and risk mitigation. By systematically deriving test cases from the decision table, the professional demonstrates adherence to best practices in software testing, which are often implicitly or explicitly mandated by quality standards and regulatory guidelines aimed at ensuring software reliability and security. This method directly maps to the principle of thoroughness and completeness in testing, a cornerstone of professional software quality assurance. An incorrect approach would be to randomly select a subset of conditions from the decision table without a systematic method for coverage. This fails to meet the implicit regulatory expectation of comprehensive testing and significantly increases the risk of undetected defects, potentially leading to non-compliance with quality standards. Another incorrect approach is to focus only on the happy path scenarios, ignoring edge cases and invalid combinations. This is a direct violation of the principle of exhaustive testing, where applicable, and regulatory bodies often require evidence that such scenarios have been considered and tested to prevent system failures or security vulnerabilities. Finally, an approach that prioritizes speed over thoroughness by creating a minimal set of test cases that do not fully represent the decision logic is also professionally unacceptable. This demonstrates a disregard for the quality assurance process and the potential impact of software defects, which can have severe consequences and lead to regulatory penalties. Professionals should employ a decision-making framework that begins with understanding the regulatory context and the specific requirements for the software under test. This should be followed by a thorough analysis of the problem domain, in this case, the business rules represented by the decision table. The chosen testing strategy, such as decision table testing, should then be evaluated against its ability to achieve comprehensive coverage and mitigate identified risks, aligning with regulatory expectations. Documentation of the testing process, including the derivation of test cases from the decision table, is crucial for demonstrating compliance and providing an audit trail. Question 13. Performance analysis shows that a newly developed feature for a critical business application is experiencing latency issues, impacting user response times. To address this, a proposed solution involves simplifying the data validation logic, which is expected to significantly improve performance. However, this simplification might reduce the robustness of the validation, potentially allowing for a wider range of input data, including some that could be considered malformed or inconsistent. Considering Boehm's quality model, which approach best balances the immediate need for performance with the long-term quality and integrity of the software. Option A. Implement the simplified data validation logic to immediately address the performance bottleneck, and plan to revisit and enhance the validation robustness in a subsequent release after monitoring user feedback and system stability. Option B. Reject the proposed simplification due to the potential for reduced validation robustness, and instead invest significant resources in optimizing the existing validation logic or exploring alternative architectural changes to improve performance without compromising data integrity. Option C. Prioritize the enhancement of data validation robustness by implementing stricter validation rules, even if it further degrades performance, to ensure the highest level of data integrity and prevent any possibility of malformed input. Option D. Implement the simplified data validation logic and concurrently develop a comprehensive set of automated tests to detect any adverse effects on data integrity or system stability, accepting a higher risk of minor data inconsistencies in exchange for immediate performance gains. The correct answer is A. Implement the simplified data validation logic to immediately address the performance bottleneck, and plan to revisit and enhance the validation robustness in a subsequent release after monitoring user feedback and system stability. Explanation. This scenario is professionally challenging because it requires a software quality professional to balance competing quality objectives derived from Boehm's quality model. The pressure to deliver a feature quickly can lead to overlooking critical quality characteristics that, while not immediately apparent, can have significant long-term consequences for user satisfaction and system maintainability. A careful judgment is required to ensure that the pursuit of one quality characteristic does not unduly compromise others, especially when regulatory compliance or industry best practices are at stake. The correct approach involves a comparative analysis that prioritizes and balances Boehm's quality characteristics based on the project's context and potential impact. This approach recognizes that, while functionality and performance are often immediate concerns, factors like reliability, maintainability, and usability are equally crucial for long-term software success and adherence to professional standards. By systematically evaluating how changes affect these interconnected characteristics, the professional can make informed decisions that align with the software quality professional (SQP) exam's emphasis on comprehensive quality assurance. This aligns with the ethical obligation of a software quality professional to deliver robust, reliable, and maintainable software, which indirectly supports regulatory compliance by reducing the likelihood of defects that could lead to non-compliance. An incorrect approach that focuses solely on immediate performance gains without considering the impact on reliability would be professionally unacceptable. This failure stems from a narrow interpretation of quality, neglecting the interconnectedness of Boehm's model. For instance, Optimizing for speed might introduce race conditions or memory leaks, directly impacting reliability and potentially leading to system failures that could have regulatory implications if the software is used in a regulated industry. Another incorrect approach that prioritizes ease of modification for future features at the expense of current usability would also be professionally unsound. While maintainability is important, sacrificing the immediate user experience for potential future ease of change is a misapplication of Boehm's model. This can lead to user frustration, decreased adoption, and ultimately, a failure to meet the software's primary objectives, which is a breach of professional responsibility to deliver value. A third incorrect approach that attempts to address all quality characteristics equally without a clear prioritization strategy would be inefficient and impractical. While a holistic view is necessary, without a framework for trade-offs and prioritization, the project could become stalled, failing to deliver any value effectively. This demonstrates a lack of strategic thinking in applying quality models. The professional decision-making process for similar situations should involve 1. Understanding the project's objectives and constraints. 2. Identifying the relevant quality characteristics from Boehm's model that are critical for the project. 3. Analyzing the interdependencies between these characteristics. 4. Evaluating potential trade-offs and their implications. 5. Prioritizing quality characteristics based on business needs, user impact, and potential risks. 6. Documenting the rationale for decisions made regarding quality trade-offs. Question 14. System analysis indicates that a software development company is experiencing recurring issues with product defects, delayed delivery schedules, and inconsistent customer satisfaction. The management team has tasked the software quality professional, SQP, with recommending a framework to establish a robust quality management system, QMS, that will systematically improve their software development processes and enhance overall product quality and customer experience. The company has a moderate level of process definition, but lacks formal process improvement initiatives. Which of the following approaches would be the most appropriate for the SQP to recommend, considering the need for structured process improvement and measurable gains in software development capability? Option A. Recommend the adoption of CMMI for development, CMMI Dev, at a suitable maturity level, focusing on process areas directly related to software development lifecycle activities, to guide the organization towards achieving higher levels of process maturity and predictable performance. Option B. Recommend the immediate adoption of a suite of advanced testing tools and automation platforms without establishing a formal QMS framework, assuming that technological solutions will inherently improve quality. Option C. Recommend the implementation of ISO 9001-2015, focusing on its general requirements for a QMS, to ensure a basic level of quality control and customer focus across all organizational functions. Option D. Recommend a series of ad hoc training sessions on various quality methodologies, without a defined framework or long-term strategy, to address immediate perceived skill gaps. The correct answer is A. Recommend the adoption of CMMI for development, CMMI Dev, at a suitable maturity level, focusing on process areas directly related to software development lifecycle activities, to guide the organization towards achieving higher levels of process maturity and predictable performance. Explanation. This scenario presents a common challenge in software development where a team is tasked with improving their software development processes. The challenge lies in selecting the most appropriate quality management system, QMS framework, to achieve specific organizational goals, such as enhancing product reliability and customer satisfaction, while adhering to industry best practices and potential regulatory expectations relevant to the software quality professional, SQP, exam's jurisdiction. The SQP must demonstrate a deep understanding of the principles and application of different QMS frameworks to make an informed recommendation. The correct approach involves selecting a framework that aligns with the organization's maturity level and strategic objectives. ISO 9000, particularly ISO 9001, provides a foundational set of requirements for a QMS that focuses on customer satisfaction and continual improvement. It is process-oriented and adaptable to various industries. CMMI, Capability Maturity Model Integration, on the other hand, is a process improvement framework that focuses on specific development and acquisition processes, aiming to guide organizations towards higher levels of capability and maturity. For an organization aiming to systematically improve its software development processes and achieve measurable gains in quality and efficiency, adopting CMMI, specifically a relevant model like CMMI for development, would be a more targeted and potentially more effective approach than a general QMS like ISO 9000, especially if the goal is to achieve higher levels of process maturity and predictable performance. The SQP's role is to analyze the current state and future aspirations to recommend the most suitable path. An incorrect approach would be to implement ISO 9000 without a clear understanding of its application to software development, or to adopt CMMI without considering the organization's current process maturity and the resources required for its implementation. ISO 9000, while a valid QMS, might not provide the granular process guidance needed for significant software development process improvement compared to CMMI. Implementing CMMI without proper planning and resource allocation can lead to a bureaucratic overhead that stifles innovation and does not yield the desired quality improvements, potentially violating the principle of efficient and effective process management. Another incorrect approach would be to focus solely on tools and technologies without establishing a robust QMS framework, as this neglects the fundamental process and people aspects of quality management. Professional decision-making in such situations requires a systematic evaluation of the organization's needs, current capabilities, and strategic goals. The SQP should first understand the specific quality objectives, then assess the existing processes, and finally research and compare the principles and implementation requirements of relevant QMS frameworks like ISO 9001 and CMMI. This involves considering the scope of each framework, its focus areas, the level of detail it provides, and the typical implementation effort and benefits. The SQP should then recommend the framework that best addresses the identified needs and aligns with the organization's capacity for change and improvement, ensuring that the chosen framework supports the overarching goal of enhancing software quality and customer satisfaction. Question 15. Quality control measures reveal that a significant number of test cases are failing due to unexpected software behavior, and upon investigation, it's determined that the input data used for these tests does not adequately represent the range of valid and invalid inputs the software is expected to handle in a real-world operational environment. As a software quality professional, what is the most appropriate course of action? Option A. Initiate a comprehensive review of the test data generation process to ensure it covers all identified requirements, boundary conditions, and error scenarios, and then update the test data accordingly. Option B. Proceed with the current test data, focusing only on test cases that are currently passing to demonstrate a high success rate. Option C. Increase the number of test cases executed with the existing test data to try and statistically compensate for its limitations. Option D. Ignore the quality control findings regarding test data and continue with the planned testing schedule, as the software is otherwise meeting development milestones. The correct answer is A. Initiate a comprehensive review of the test data generation process to ensure it covers all identified requirements, boundary conditions, and error scenarios, and then update the test data accordingly. Explanation. This scenario presents a professional challenge because the integrity of software quality testing is directly compromised by the use of inadequate test data. The SQP professional is tasked with ensuring that the software meets its quality objectives, which includes verifying its behavior under various conditions. Inaccurate or incomplete test data can lead to false positives or negatives, masking critical defects, and potentially leading to the release of faulty software. This has significant implications for user trust, regulatory compliance, and the reputation of the development organization. Careful judgment is required to identify the root cause of the issue and implement a corrective action that aligns with professional standards and regulatory expectations. The correct approach involves a systematic review of the test data generation process to identify and rectify the underlying issues. This includes understanding the requirements for test data, ensuring it adequately covers expected inputs, boundary conditions, and error scenarios, and validating its accuracy and completeness. This approach is professionally sound because it directly addresses the root cause of the quality control findings. It upholds the principle of thorough testing, which is a cornerstone of software quality assurance. Furthermore, by ensuring test data is fit for purpose, It supports the organization's commitment to delivering reliable and compliant software, aligning with the ethical obligations of a software quality professional to act with integrity and competence. An incorrect approach that relies solely on increasing the volume of test data without addressing its quality is professionally unacceptable. This fails to recognize that simply having more data does not guarantee better testing if the data itself is flawed. It represents a superficial fix that does not resolve the fundamental problem of inadequate test coverage or accuracy, potentially leading to continued undetected defects. This approach also risks wasting resources on ineffective testing efforts. Another incorrect approach, which involves ignoring the findings and proceeding with the current test data, is a severe ethical and professional failure. This demonstrates a disregard for quality control processes and a lack of commitment to delivering a high-quality product. It directly violates the professional duty to identify and report defects and to ensure that testing is conducted rigorously. This can lead to significant downstream consequences, including regulatory noncompliance, financial penalties, and reputational damage. A third incorrect approach, which involves selectively using only the test data that yields positive results, is also professionally and ethically unsound. This practice is a form of manipulating test outcomes to present a falsely positive view of software quality. It undermines the objectivity and integrity of the testing process and is a direct contravention of professional ethics, which demand honesty and transparency in reporting test results. This approach actively conceals defects and misleads stakeholders about the software's readiness for release. The professional decision-making process for similar situation should involve a structured approach. First, thoroughly understand the quality control findings and their implications. Second, investigate the root cause of the identified issues, in this case, the inadequacy of test data. Third, evaluate potential solutions based on their effectiveness in addressing the root cause and their alignment with professional standards and regulatory requirements. Fourth, implement the chosen solution with appropriate documentation and verification. Finally, communicate findings and actions taken to relevant stakeholders to ensure transparency and continuous improvement. Question 16. System analysis indicates that a new software development project is commencing with a tight deadline and limited resources. The project manager is proposing to postpone the formal creation of a software quality assurance plan, SQP, until the development phase is well underway, suggesting that quality activities can be addressed as they arise. What is the most appropriate SQA activity to undertake at this initial project stage? Option A. Develop a comprehensive software quality assurance plan, SQP, that outlines quality objectives, processes, standards, and metrics for the entire project lifecycle. Option B. Create a generic SQP that is not tailored to the specific risks and requirements of this particular project. Option C. Defer the creation of a formal SQP until the development phase is significantly advanced, focusing initially on core development tasks. Option D. Implement ad hoc testing procedures by developers as needed, without a documented plan or defined quality metrics. The correct answer is A. Develop a comprehensive software quality assurance plan, SQP, that outlines quality objectives, processes, standards, and metrics for the entire project lifecycle. Explanation. This scenario presents a common challenge in software quality assurance, balancing the need for robust quality planning with the pressures of rapid development cycles and resource constraints. The professional challenge lies in ensuring that quality is not an afterthought, but is integrated throughout the development lifecycle, adhering to established quality management principles and regulatory expectations without stifling innovation or causing undue delays. Careful judgment is required to select the most effective and compliant approach to SQA planning. The correct approach involves proactively establishing a comprehensive software quality assurance plan, SQP, that defines the processes, standards, metrics, and activities to be undertaken throughout the project lifecycle. This plan should be developed early in the project, ideally during the planning phase, and should be a living document, subject to review and updates as the project evolves. This proactive stance aligns with the principles of quality management frameworks, such as ISO 9001, which emphasize a systematic approach to quality. Specifically, it addresses the regulatory expectation for documented quality processes and the ethical responsibility to deliver a product that meets defined quality standards and stakeholder requirements. By planning for quality upfront, the team can identify potential risks, allocate resources effectively, and establish clear quality objectives, thereby minimizing defects and ensuring compliance with any applicable industry-specific regulations or standards that mandate certain quality assurance practices. An incorrect approach would be to defer the creation of a formal SQP until after the development phase has begun or is nearing completion. This reactive strategy often leads to rushed and incomplete quality planning, where activities are implemented ad hoc rather than as part of a structured, integrated process. This can result in missed quality objectives, increased rework, and a higher likelihood of noncompliance with regulatory requirements that expect a demonstrable commitment to quality throughout the development lifecycle. Another incorrect approach is to rely solely on ad hoc testing performed by developers without a documented plan or defined quality metrics. While developer testing is a valuable component of software quality, it is insufficient as the sole SQA activity. This approach fails to establish a systematic framework for quality monitoring and control, making it difficult to objectively assess the overall quality of the software or to demonstrate compliance with any quality assurance mandates. It also neglects the crucial planning and improvement aspects of SQA. A third incorrect approach would be to create a SQP that is overly generic and does not address the specific risks, requirements, and context of the project. A plan that lacks specificity or is not tailored to the project's unique characteristics will be ineffective in guiding quality efforts. This can lead to the implementation of irrelevant or insufficient quality activities, failing to meet the project's quality goals, and potentially contravening regulatory expectations for a fit-for-purpose quality management system. The professional reasoning process for such situations involves understanding the project's objectives, constraints, and regulatory landscape. It requires prioritizing proactive planning and integrating SQA activities into the project lifecycle from the outset. Professionals should consult relevant quality standards and regulatory guidelines to ensure their plans are compliant and effective. When faced with pressure to compromise on quality planning, professionals must articulate the risks associated with such compromises and advocate for a systematic, planned approach to quality assurance. Question 17. Cost-benefit analysis shows that a comprehensive testing strategy is essential for minimizing post-release defects, but the SQP must select the most efficient method for identifying errors at input data limits. Considering the regulatory imperative for robust software quality and the common occurrence of defects at input thresholds, which testing approach best balances efficiency with thoroughness in identifying potential software failures at the edges of valid input ranges? Option A, testing only the maximum possible input values for each data field. Option B, testing a few arbitrary values within each equivalence class without specific focus on limits. Option C, testing only within the typical or nominal values of equivalence classes, avoiding extreme inputs. Option D, systematically testing at the boundaries of equivalence classes, including values just inside and just outside these boundaries. The correct answer is D, systematically testing at the boundaries of equivalence classes, including values just inside and just outside these boundaries. Explanation: this scenario is professionally challenging because it requires a software quality professional, SQP, to balance the efficiency of testing with the imperative of ensuring software reliability, particularly at critical input boundaries. The challenge lies in identifying the most effective testing strategy that minimizes risk without incurring excessive development or testing costs. The SQP must demonstrate sound judgment in selecting testing techniques that align with regulatory expectations for software quality and safety. The correct approach involves systematically identifying equivalence classes and then specifically testing at the boundaries of these classes, including just inside and just outside the boundaries. This is considered best professional practice because it is a highly efficient technique for uncovering defects. Boundary value analysis, BVA, is a direct application of the principle that errors often occur at the extremes of input ranges. Regulatory frameworks for software quality, such as those governing critical systems e.g., medical devices, financial services, aviation, implicitly or explicitly mandate thorough testing to ensure software functions correctly under all expected and foreseeable conditions. By focusing on boundaries, SQPs maximize the probability of finding defects with a relatively small number of test cases, thereby fulfilling the professional obligation to deliver robust and reliable software. This aligns with the ethical duty to protect users and stakeholders from software failures. An incorrect approach that focuses solely on testing within the typical or nominal values of equivalence classes fails to address the most common sources of errors. This approach neglects the critical edge cases where software is most likely to break, leading to potential regulatory noncompliance if the software is used in regulated industries. Such a failure could result in significant financial penalties, reputational damage, and harm to end users. Another incorrect approach that involves testing only a few arbitrary values within each equivalence class, without regard for boundaries, is similarly flawed. While it might cover some functional aspects, it misses the crucial boundary conditions. This lack of thoroughness can lead to undetected defects that manifest under specific, often critical, operational circumstances, again risking regulatory noncompliance and potential harm. A third incorrect approach that prioritizes testing only the maximum possible input values, without considering minimums or values immediately adjacent to boundaries, is also insufficient. This approach is too narrow and fails to capture errors that might occur at the lower end of a range, or when an input is just slightly above or below a valid threshold. This selective testing creates blind spots, increasing the likelihood of releasing software with critical vulnerabilities. The professional decision-making process for similar situations should involve 1. Understanding the software's requirements and intended use, especially in regulated environments. 2. Identifying equivalence classes for input data. 3. Applying boundary value analysis to systematically define test cases that cover the boundaries of these classes. 4. Considering the risk associated with potential failures at each boundary. 5. Documenting the testing strategy and rationale, ensuring it meets or exceeds relevant industry standards and regulatory expectations. 6. Continuously evaluating the effectiveness of the testing approach and adapting it as necessary. Question 18. The performance metrics show a significant increase in user-reported errors related to data processing within a newly deployed module. As the SQP, you have limited, but some, documentation regarding the internal data flow and error handling mechanisms of this module, but not full source code access or detailed architectural diagrams. Which testing approach would best leverage this partial knowledge to identify the root cause of these errors? Option A. Design test cases that specifically target the documented internal data flow paths and error handling routines, using the partial documentation to guide input data and expected outcomes. Option B. Attempt to infer the internal structure through extensive trial and error input manipulation and observe system behavior without any reference to the existing partial documentation. Option C. Focus testing efforts exclusively on the areas of the module for which detailed internal documentation is available, ignoring other parts of the module. Option D. Conduct purely black box testing by focusing on end-to-end user scenarios and observing system responses without any consideration for the internal workings. The correct answer is A. Design test cases that specifically target the documented internal data flow paths and error handling routines, using the partial documentation to guide input data and expected outcomes. Explanation. This scenario is professionally challenging because it requires a software quality professional, SQP, to balance the need for thorough testing with the constraints of partial internal knowledge. The SQP must make a critical decision about the most effective testing strategy, given limited visibility into the system's architecture and code. This requires careful judgment to ensure that testing efforts are both efficient and effective in identifying potential defects, thereby upholding the professional responsibility to deliver quality software. The correct approach involves leveraging the available partial knowledge of the internal structure to design test cases that probe specific functionalities or potential weak points identified through this limited insight. This aligns with the principles of gray box testing, which seeks to optimize testing by combining external perspectives with an understanding of internal workings. From a regulatory and ethical standpoint, this approach demonstrates due diligence. It shows a proactive effort to test beyond a purely black box perspective, aiming to uncover defects that might be missed otherwise, thereby contributing to the overall integrity and reliability of the software, which is a core tenet of professional software quality assurance. An incorrect approach would be to proceed with purely black box testing, ignoring the partial internal knowledge. This fails to capitalize on the opportunity to design more targeted and potentially more effective test cases, leading to a less comprehensive quality assessment and potentially overlooking critical defects. Ethically, this could be seen as a failure to exercise professional judgment to maximize testing effectiveness. Another incorrect approach would be to attempt to reverse engineer or guess at internal structures without any concrete partial knowledge, leading to speculative and potentially irrelevant test cases. This wastes resources and does not contribute meaningfully to quality assurance, potentially violating the professional obligation to conduct testing in a systematic and evidence-based manner. A further incorrect approach would be to over-rely on the partial knowledge to the extent that it leads to biased testing, focusing only on areas where internal understanding exists and neglecting other critical areas of the software. This can result in a skewed quality assessment and a failure to identify defects in less understood parts of the system, which is a professional failing in ensuring comprehensive quality. The professional reasoning framework for such situations involves 1. Assessing the available information, partial internal knowledge. 2. Identifying the testing objectives and constraints. 3. Evaluating different testing strategies, black box, white box, gray box, in light of the information and objectives. 4. Selecting the strategy that offers the best balance of effectiveness, efficiency, and risk mitigation. 5. Documenting the rationale for the chosen approach. Question 19. Investigation of how a software quality professional should apply quality models to ensure the software meets the diverse needs of its end users, the development team, and the project sponsors, considering the primary regulatory framework for software quality professionals. Option A. Implement a quality model that focuses on a comprehensive set of industry-standard quality attributes, ensuring all potential aspects of quality are addressed, even if some are of lower priority to key stakeholders. Option B. Select a quality model that prioritizes measurable technical attributes like code complexity and test coverage, as these are directly controllable by the development team and can be objectively verified. Option C. Adopt a quality model that is most familiar to the lead developer, as their expertise will ensure efficient implementation and adherence to the chosen framework. Option D. Engage stakeholders to identify their most critical quality concerns, and then select and tailor a quality model that directly addresses these prioritized needs, ensuring alignment between quality efforts and stakeholder value. The correct answer is B. Select a quality model that prioritizes measurable technical attributes like code complexity and test coverage, as these are directly controllable by the development team and can be objectively verified. Explanation. This scenario presents a professional challenge because it requires balancing the diverse and often competing needs of different stakeholders in a software development project, specifically concerning the application of quality models. The challenge lies in translating abstract quality goals into tangible, measurable outcomes that satisfy each stakeholder group, while adhering to the regulatory framework governing software quality professionals. Careful judgment is required to ensure that the chosen quality model and its application genuinely address the most critical concerns and align with the project's objectives and the professional's ethical obligations. The correct approach involves selecting and applying a quality model that demonstrably addresses the primary concerns of the most critical stakeholders, as identified through a structured process. This approach is right because it prioritizes the effective use of resources and ensures that the quality efforts are directed towards achieving outcomes that are valued by those who have the most significant interest in the software's success. Regulatory frameworks for software quality professionals often emphasize a client-centric approach and the delivery of value, which this method directly supports. Ethically, it aligns with the duty to act in the best interests of the client and to ensure the software meets its intended purpose and user needs. An incorrect approach that focuses solely on technical metrics without considering their impact on user experience or business objectives fails to meet the broader definition of quality. This is a regulatory failure because it may lead to software that is technically sound but practically unusable or does not deliver the expected business value, potentially violating implicit or explicit contractual obligations to deliver a fit-for-purpose product. It is also an ethical failure, as it neglects the broader impact on end users and the organization's strategic goals. Another incorrect approach that prioritizes a single stakeholder's preferences without considering the needs of others can lead to an imbalanced or suboptimal outcome. This is a regulatory failure because it may result in a product that, while satisfying one group, is deficient in areas critical to other stakeholders, potentially leading to project failure or dissatisfaction. Ethically, it demonstrates a lack of fairness and a failure to consider the holistic impact of the software. A third incorrect approach that adopts a quality model without a clear understanding of its applicability to the specific software and its context risks misdirecting quality efforts. This is a regulatory failure because it may lead to the implementation of inappropriate processes or metrics, wasting resources and failing to achieve the desired quality improvements. Ethically, it represents a lack of due diligence and professional competence in applying quality principles. The professional decision-making process for similar situations should involve a thorough stakeholder analysis to identify key concerns and priorities. This should be followed by a selection of quality models that are appropriate for the software's domain, development lifecycle, and stakeholder needs. The application of the chosen model should be iterative, with continuous feedback loops to ensure that quality objectives are being met and that adjustments can be made as necessary. Professionals must always consider the regulatory requirements and ethical implications of their decisions, ensuring transparency and accountability throughout the quality assurance process. Question 20. Operational review demonstrates that the current test design techniques employed for the new financial reporting module are overly focused on internal code structure and are not effectively validating the accuracy and usability of the reports from a business user's perspective. Which approach to test design techniques would best address this deficiency and align with professional quality standards? Option A. Introduce more complex structural testing techniques to achieve higher code coverage metrics, thereby ensuring the underlying code is robust. Option B. Focus on exploratory testing sessions to uncover unexpected defects without predefined test cases, relying on tester intuition. Option C. Implement equivalence partitioning and boundary value analysis to ensure comprehensive input validation for all data fields within the reporting module. Option D. Prioritize test design techniques that directly map to business requirements and user workflows, ensuring traceability and clear communication of test outcomes to business stakeholders. The correct answer is C. Implement equivalence partitioning and boundary value analysis to ensure comprehensive input validation for all data fields within the reporting module. Explanation. Scenario analysis. This scenario presents a common challenge in software quality assurance, where the technical implementation of test design techniques must align with the broader business objectives and stakeholder expectations. The professional challenge lies in translating abstract quality goals into concrete, verifiable test cases that provide meaningful assurance to diverse stakeholders, including business users, regulatory bodies, if applicable to the specific SQP exam jurisdiction, and the development team. The need for careful judgment arises from balancing the thoroughness of testing with the practical constraints of time and resources, ensuring that the chosen techniques deliver the most effective risk mitigation and value. Correct approach analysis. The correct approach involves selecting test design techniques that directly map to the identified business requirements and risks, ensuring that the tests validate the software's ability to meet user needs and regulatory compliance, as defined by the SQP exam's jurisdiction. This stakeholder-centric perspective ensures that testing efforts are focused on areas of highest business impact and potential failure. By prioritizing techniques that provide clear traceability to requirements and facilitate effective communication of test results to non-technical stakeholders, this approach maximizes the value of the QA process and builds confidence in the software's quality. The regulatory framework for SQP exams emphasizes the importance of delivering software that meets defined standards and stakeholder expectations, making this a professionally sound and ethically responsible choice. Incorrect approaches analysis. Focusing solely on technical complexity without regard for business value leads to tests that may be intricate but do not address critical business risks or user needs. This fails to provide adequate assurance to stakeholders and can result in a misallocation of testing resources, a regulatory failure if the software does not meet its intended purpose or compliance standards. Adopting techniques that are easy to implement but offer limited coverage or insight into critical functionalities means that significant risks may go undetected. This approach neglects the professional responsibility to ensure a reasonable level of quality and can lead to the release of defective software, potentially violating ethical obligations to deliver reliable products. Prioritizing techniques based on personal preference or familiarity, rather than their suitability for the specific software and its context, demonstrates a lack of professional diligence. This can result in suboptimal test coverage and an inability to effectively communicate the software's quality status to stakeholders, undermining the credibility of the QA process and potentially leading to noncompliance with quality standards. Professional reasoning. Professionals should adopt a decision-making framework that begins with a thorough understanding of the software's business context, objectives, and associated risks. This understanding should then guide the selection of test design techniques, prioritizing those that offer the best balance of coverage, efficiency, and stakeholder communication. Regular consultation with stakeholders to validate the testing strategy and communicate results is crucial. The SQP framework mandates a commitment to delivering quality software that meets defined requirements and ethical standards, necessitating a proactive and stakeholder-aligned approach to test design.